So this morning we've been talking about PowerShell remoting by connecting to the Windows Remote Management Service, the WinRM service, at the target box. But there are other ways to do remote command execution with PowerShell. In the next section, we're going to discuss SSH, Secure Shell, and specifically it's a particular implementation of SSH, the most popular one called OpenSSH. SSH is a protocol. It's Secure Shell. Secure Shell has been around for many years. It's mostly associated with Linux and Unix like BSD. We get several benefits when we use SSH. We get strong encryption and mutual authentication. And that authentication, by the way, that could be key-based. In fact, we have a lab coming up. We're going to generate public-private key pairs and then use those public-private key pairs for doing mutual authentication. That means we authenticate the target machine with its public key, and the target authenticates us, the user or the client, with our public key. SSH also supports other authentication methods too, like password authentication. That's not ideal. But in an Active Directory environment, you can also use Kerberos. One of the main benefits of SSH is its cross-platform compatibility. Today, most of us work in mixed environments. You might have Windows on the desktop, Linux on most of your servers, Windows, of course, for your domain controllers, and then a variety of other operating systems for special appliances. For example, you might have network-attached storage servers. Maybe you have FreeNAS or TrueNAS, so that runs BSD Unix in the background. Or you might connect to IoT devices, running a custom operating system for that IoT device, but it could support SSH for remote administration. So we're all going to be working in heterogeneous environments like this for the foreseeable future. So it's nice to have one solution for doing remote command execution. Now, for the sake of PowerShell, PowerShell Core has built-in integration for SSH. For example, when you're remote into another machine with enter PS session, is using the SSH client tool secretly in the background. And if you're using a command like invoke command, that's the PowerShell command, if you run invoke command, well then instead of talking to the WinRM service, it's going to talk to the SSH service or daemon at the target machine. And again, at the remote machine, it'll execute a PowerShell command for you. That output will be converted to XML. The XML streamed back over the network to you, encrypted with SSH, and then on your client device inside PowerShell Core, the XML will be converted back into true objects again, objects with properties. You can also use SSH for uploading and downloading files. SSH includes a command line tool, SFTP. Now, despite the name, it's not actually using File Transfer Protocol, but it's modeled on that. So if you're familiar with FTP and the concepts and tools like local versus remote working directories and file globbing, things like that, well, then you can use the SFTP tool for SSH to also upload and download files. You can also use SSH for port forwarding, also called port tunneling. You could use this, for example, for connecting to an SSH server as like a SOCKS server for forwarding through browser connections to web servers beyond the SOCKS server. You could also set up that box as a true VPN gateway and use SSH as your VPN tunneling protocol. And SSH works just fine on standalones. So you don't have to have domain joined machines. You won't get Kerberos on those standalone boxes, but you can use public-private key pair authentication. So we have several benefits for using SSH, and beyond security, I think the reason that you will likely have to use SSH, even if you don't want to, is because we all work in, heterogeneous environments with a mixture of Windows, Linux, BSD, and other operating systems as well. Now, what about the downsides? What are the bad things about it, or at least the inconvenient things? SSHD, that's the SSH service. And that service is not installed by default. So the WinRM service, that's installed, and on Windows Server 2012 and later, not only is it installed by default, it's configured and running by default. But at least that service is installed by default even on Windows 7 and Windows 10. So through group policy or through a few PowerShell commands, we could enable and configure the WinRM service for normal traditional PowerShell remoting. But for the sshd service or daemon, that has to be installed before, of course, it can even be configured. Now, how is it installed? The SSH client tools are installed on recent operating systems, but the SSH daemon or service is not installed at all. Now, this can be installed using Windows tools, like for example, going to the All Settings app. But when you do it this way, you get an older version of the SSH service. And probably you want the most recent version to get the bells and whistles. And if there's a new security vulnerability that is published for SSH, that vulnerability will probably be fixed in GitHub for the SSH daemon source files. That'll probably be fixed within just a few days. And then within just a few days, you'll be able to download the latest files, upgrade your locally running version of the SSH service, and now you're immune to the vulnerability. Now, on the other hand, if you're using Microsoft Update or Windows Update, and are using the built-in version of SSH, well then literally you might have to wait weeks or months. I mean, imagine that scenario where you've got machines exposed to the internet, you're using SSH to remotely access those boxes, so you're listening on TCP port 22, that's the default port number for SSH. You've got all these servers or other machines exposed to the internet, there's a nasty vulnerability. That vulnerability is fixed in the source code files for SSH in GitHub, but you have to wait, let's say, 2 months before Microsoft to update the built-in version of SSH. In other words, it would be intolerable. In fact, the lab that we're about to do in just a little bit, we're going to install the SSH service on our machines, but we're using the GitHub version. It doesn't mean you have to do it by hand. We're going to run a script that'll do everything for us. And of course, you could use and modify that script for installing and updating the SSH service on your boxes. But just keep in mind that we are now stepping outside of the normal Windows Update or Microsoft Update servicing regimen, right? You know, the every second Tuesday when new patches come out. Now, once we're installing and managing SSH directly from GitHub, that means we're doing it ourselves. So on the good side, if there is a new vulnerability, or if there's a new bell and whistle that we want to use with SSH, well, we can get it very quickly because we're getting it directly from the source. We're getting it from GitHub. But on the downside, we have to do it ourselves, right? All right, so the GitHub version is more recent, has more bells and whistles. If there's a vulnerability, will likely be fixed quickly. But on the other hand, when you run Windows Update or you're using a WSUS server, for example, well, in this case, we are now doing it ourselves, side channel, so to speak, from GitHub. And now Windows Update, Microsoft Update, your WSUS servers, and all of those products that revolve around that updating system from Microsoft, now we just can't use that. We're out of luck. All right, so the recommendation from a security perspective is to definitely get it from GitHub. But of course, that is going to make it a little bit more difficult to manage and patch, because now we're scripting that management and patching ourselves. Now, it could be that in a couple years, the version of SSH that is built into Windows will have all the bells and whistles that we want. And in that case, maybe it'd just be easier to going back to using the older version of SSH that comes with Windows or that comes directly from Microsoft. And then we can simplify our patch management, because now normal patch management, like with your WSUS servers, will update SSH as well. But we're not there yet. The SSH server that's built into Windows today is rather old and is missing features that we really want. The SSH service for Windows is going under active rapid development. And roughly every 3 to 6 months, there are new features that we really want. All right, so that is a negative to be aware of. Now, another issue, and this is true for all versions of SSH, whether you install from Microsoft or from GitHub, or if you have Linux or BSD, and that is the complexity of managing keys. So we're going to see that we can generate public-private key pairs. Those public keys can be added to remote machines for single sign-on authentication, where you can authenticate with a key instead of a password. Now, yes, this is convenient once it's set up, but the problem is setting it up and managing it across thousands of boxes. Now, this can be a huge problem to deal with. So you may have heard other people say that SSH is great, it's so easy to set up, but when you ask them the details, you find out that they're only using SSH on a relatively small number of boxes, and they are rarely, if ever, rotating their keys. In other words, from a security perspective, you're supposed to rotate out and stop using your old keys and then use new keys. So that key rotation problem, we want to rotate or update our keys like at least every 6 months or so. And of course, what if there's a security incident? If we know our adversaries have been stealing private keys from boxes and now they're using SSH key-based authentication, well then we need to immediately change or rotate our keys potentially on every server and workstation in the organization. Now, do you have the infrastructure for that, the scripts for it, the tools, and so on? We're going to use OpenSSH. We're not going to purchase any third-party products for this. Now, if you want to purchase third-party products that have SSH management capabilities built in, that's great. But I didn't want this course to be how should I put it, like a sales pitch, right, for any particular vendor's management solution for this. And besides, what is built into Windows is just the standard vanilla OpenSSH solution. So if you are happy with a third-party product that layers on top of OpenSSH or totally replaces OpenSSH with a different SSH implementation entirely, then by all means, of course, go for that. But we're going to stick with what's built in and with what Microsoft's own developers are working on. Another reason for this too, this is a PowerShell course. Do we know whether or not PowerShell or PowerShell Core is compatible with that third-party solution? So I don't know. I haven't researched all the third-party SSH solutions for Windows, but Microsoft certainly doesn't talk about any of these products. And I know that Microsoft's developers, Microsoft's PowerShell developers, they only write and test their code for the OpenSSH solution, not for any third-party solutions. We're also going to see on the downside that the configuration settings for SSH on both the client side and the server side, these settings are not stored in the registry, they're stored in text files. And there are many bells and whistles available inside of these text files. So the good thing about that is we have the bells and whistles. SSH is highly configurable, lots of knobs and dials that we can fine-tune to maximize security and convenience and do some really interesting things. And we're going to see many of these bells and whistles coming up the next few slides. But on the other hand, right, these are things we have to know about and worry about. For example, if you're not familiar with SSH port forwarding or SSH tunneling, well, this is a very powerful capability. And if you're not familiar with this, and if you don't intend to use it, it definitely should be turned off on every server and workstation. So this is a powerful capability of SSH, and if it's not managed correctly, it can open up backdoors and lead to havoc in the organization as hackers are abusing SSH, moving laterally from machine to machine inside the LAN. So again, bells and whistles are great when you need those bells and whistles. It's highly configurable, but on the other hand, this is a new major product to know about. For example, we have several long labs coming up looking at these configuration files and all of the bells and whistles. And in comparison to PowerShell remoting with the WinRM service, SSH is at least, I would say, 5 times more complex. And that's because, again, in part, of these bells and whistles. All right, and one last thing too. Be aware that today we talked about GS sandboxes for PowerShell remoting. SSH does not support that. So a GS sandbox is implemented by the WinRM service. That's for traditional PowerShell remoting. Do we have something kind of like a sandbox with the SSH service? Well, yes and no. We're going to see some examples of this coming up later, but just keep in mind that when you want a true PowerShell GS sandbox, that requires traditional Windows PowerShell remoting with the WinRM service. So the SSH service on Windows does not support GS sandboxes. It supports something similar, but it's not exactly the same thing. Can you do PowerShell remoting from Linux using PowerShell Core into a Windows machine using Windows PowerShell, yes you can. In fact, we're going to see a lab, not using Linux, but we're going to see a lab that is very similar to that. Another question is, can you download from GitHub and then push it out with System Center, Configuration Manager, SolarWinds, or whatever my favorite configuration management product is? Definitely. In fact, the script that we're going to run to install the SSH service, I deliberately wrote to make it as easy as possible to incorporate or to use along with other configuration management systems. So if you like using System Center, Puppet, Chef, Ansible, or just scheduled tasks for that matter, you should be able to relatively easily modify this script that we're going to run in our labs so that you can use it with any of those third-party or Microsoft products. Another question is, does that work in the other direction as well, managing Linux machines from Windows? Absolutely, no problem. There's lots of bells and whistles for SSH. There's lots of files and tools related to SSH. I wanted to have one slide mainly in your manual as like a cheat sheet for the exam and for real life. Because if you're totally new to SSH, it can be a little bit overwhelming. There's all these weird files. Some of them are keys. Some of them are configuration files. Some of these configuration files are on the client side. Some are on the server side. And then, of course, we have all the binaries. Some of the binary tools you run on the client side, and other binaries you run on the server side. So this one slide kind of summarizes all the different files and all the different binaries so that you can refer back to this slide in real life or for the exam. Now, what do these files do and how do we use them? That's what's coming up over like the next 20 slides or so in your book. This part of your manual is about 100 pages long. So this kind of summarizes the different tools and configuration files that we're going to be talking about. And I just know from experience, it can be, you can easily lose sight of the forest because of all these trees in the way, right? All these files in the way. And as you're going through the labs, it can be a little bit overwhelming as we're editing this one file and copying a key to another machine and back and forth. But there's no other way to do it. You just have to get hands-on experience. And that's why the labs in this part of the manual are some of the longest labs, because I think if we just talk about it in the abstract, there's just so many, different files with similar names and whatnot. It's just so easy to lose track. And really, there's no substitute here, especially for SSH, no substitute for getting lots of hands-on practice. So some of the longest labs in this entire 6-day course are actually coming up in this module. All right, so this slide here is more of a reference. One thing I do want to point out on the slide is notice this little squiggly line. That little squiggly line is called a tilde, and that in PowerShell core is an alias for one of your local profile folders. So for example, on my machine, I've just switched to PowerShell core in my box. If I do cd tilde, the squiggly line, then now I'm in my local profile folder. I have a subdirectory. Once I've configured SSH, I have a subdirectory named .ssh. Now I can also do cd $home, and notice that that is the exact same folder. I can also do cd and then the environmental variable user profile, and notice that that is the exact same folder. So that means we have 3 different ways of referring to the exact same folder. We have the tilde, the squiggly line. We have $home, like in PowerShell core. And we also have in all versions of PowerShell, we have the environmental variable for the user profile folder. Throughout the labs then, I tend to use the tilde because it's a single character. And also, when you're managing SSH on Linux boxes, then typically that is the character which is used to refer to the path to your home directory. There's client binary tools, and there's the server side. There's a binary that runs on the server. That's the target machine. That's the service or daemon that we're talking to. Now for the client tools, the 2 most important of these tools are ssh.exe and sftp.exe. SSH is the main SSH client tool, That's how you can get a remote command shell on another box, and secretly that's what's used in the background when you're using PowerShell commands that are integrated with SSH. So with PowerShell core, when you're using commands like enter ps session or invoke command, those PowerShell commandlets are secretly using ssh.exe in the background. So it's not the case that PowerShell core has its own separate DLLs, let's say, that implement the SSH protocol. Those PowerShell commands are wrappers for ssh.exe. SFTP, that's for uploading and downloading files. Now, these client tools that you might find on your laptop, for example, you'll also find on Server 2019, Windows 10 version 1803, and later. You can install these client tools on older operating systems as well, but these are the OSs that have it built in by default. However, these are the older versions. These are the older versions of these client binary tools. Yes, they are patched and maintained, like through Windows Update, or if you're using a WSys server as your patch management server. But these are the older versions. The newer versions are better. The newer versions are in GitHub. So there's the path in your slide to where you go in GitHub to download the latest versions of these binaries and the source code if you wish. When you install SSH onto a machine, you have to ask, am I installing the client tools, the server side, or both? And typically, you're going to install both. So in the lab, in just a few minutes, you're going to run a script that will copy the new binaries from GitHub, which are already there in your SANS folder. They're going to copy the new binaries from GitHub to your machine, and we're going to use those instead of the built-in ones. Now, how is that accomplished? When you run ssh.exe or sftp.exe, why is it that you're running the new ones from GitHub instead of the old ones that are built into Windows by default? It's because we're going to update our path environment variable. Your path environment variable has a list of all the folders on your hard drive that Windows searches when you execute a command. So what we want is that when we run ssh.exe, your machine will find it by looking at the path environment variable, and it'll go to the new folder where we are copying these binaries to, instead of the subdirectory underneath Windows where the built-in binaries are found. In other words, we are just going to totally ignore and not use the built-in Windows binaries for SSH, either on the client side or on the server side. Now that means, for patch management then, if you are installing the latest versions of SSH, both the client tools and the server tools from GitHub, that means you're getting those binaries from GitHub, maybe putting them into a zip file, maybe an MSI package that you make yourself, rolling it out to your boxes. There are lots of ways that you can do this. Again, if you have System Center or any other enterprise management product, most of these products will allow you to create your own custom installation packages, and then you can overwrite the binaries that exist on the drive. But don't forget, you also have to update the path environment variable. So I have a PowerShell script for you. It's named update path environment variable for OpenSSH. So there's no doubts, right, about what that script does. So when you run that script, it modifies your path environment variable for you so that it removes the SSH binaries path from that variable, the one that's built in from Microsoft, and then adds the new one. So we're going to install our SSH binaries from GitHub into a folder underneath the program files subdirectory. So if you have, for example, /program files whack OpenSSH, that's where Microsoft recommends that these binaries be placed. So that's what we're going to do. And in the lab then, we're going to update our path environment variable to point towards that folder. You also have another script that you're going to run in the lab, and when you run that script, it'll show you your path environment variable. It'll show you all the SSH binaries that you have on the drive, including where they're located, and also the version of those binaries. Because if you're troubleshooting, one of the first things to check is, well, what version of the SSH client binaries or server binaries am I running, and where are they located? So you have a troubleshooting script in your SANS folder, and you're about to run this in the lab in just a little bit. Now, what about configuration files? OpenSSH stores its configuration settings in text files, not in the registry. There's a special folder named .ssh, that's not a typo, and that folder is in your local profile folder, and that's where these configuration files and keys can be stored. That folder does not exist by default. The first time you run one of these SSH client binaries, it'll look for that folder, and if it doesn't exist, it's created on the fly. So if you're looking right now on your machine for that folder, it doesn't exist. But the first time you run one of these commands, then that folder will be created automatically. As I mentioned a few minutes ago, be aware that the tilde, the squiggly line, is like an alias for $home, which is like an alias for the user profile environment variable, which is like an alias, right, for your local profile folder. So those 4 paths that are shown here in the slide in blue, those 4 paths all refer to the exact same folder on the hard drive. There's the full explicit path, it's the last one, the one in blue at the bottom. So if you're logged on as administrator, then your local profile folder is almost certainly going to be c:\users\administrator. That's your local profile folder. Because these configuration files are just text files, that means we can script the management of these files. And it also means that we can use things like group policy and system center to manage these files too. So in today's manual, by the way, first we're going to talk about SSH, and then after that do a little bit of group policy. And just be aware that through group policy, you can overwrite files on your users' machines, including their SSH configuration files. And because these are relatively simple text files, we can also script the management of the files. So for example, if you wanted to comment or uncomment a keyword in one of these files, that can be relatively easily scripted if that's how you want to install it. Very often though, the easiest way to manage these settings is to have a handcrafted file with just the settings that you want, and then simply copy it to the target machines, overriding whatever file is already there. So just be aware, these OpenSSH config settings are not in the registry. They're stored in textual config files. And so a lot of your OpenSSH administration is the editing of these text files. We can do that by hand with a text editor like Notepad, but it can also be scripted out. Now, what about the server side? This is what you are connecting to. This is the target. The SSH server service is named sshd because the binary on the drive is sshd.exe. So this can be a little bit confusing, but ssh.exe, that's the client tool. sshd.exe, that's the server side, that's the target that we are connecting to. D in this case stands for daemon. Daemon is another word for service. So the SSH service or the SSH daemon, those are the exact same thing. That's on the target machine that you are connecting to. The SSH daemon is not installed in any version of Windows by default, at least not yet. Now maybe someday in the future, the SSH daemon will be installed by default, maybe not configured, but installed by default perhaps, but not yet, and probably not for at least a couple years. So when we SSH into a target machine, the SSH daemon or service has to be installed, configured, and running at the target. As I mentioned before, there are 2 different ways that we can install the SSH service on our target machines. Now, one way is to use Microsoft's, how should I put it, blessed or approved binaries. And now you could go to the All Settings app, go to your list of Windows features, and just click the button for it. You actually have a screenshot of that in your manual. In your manual, it'll walk you through all these steps if that's what you want to do. If you want to script it out from the command line, then in PowerShell, you could use the Add Windows Capability tool. And again, this will connect over the internet to Microsoft, download the binaries, and install it on your box. In either case though, whether you're using the PowerShell Add Windows Capability tool, or you're using the All Settings app, that's the new control panel, you have to have internet access because you're downloading the binaries directly from Microsoft. So if you're working in an air gap, you won't be able to use this method at all. So if you were forbidden from accessing the internet from, let's say, your jump server or other critical machines inside the LAN, you won't be able to use this method at all to install it. Instead, we'll get it from GitHub, and that's method number 2. When you get the binaries from GitHub, you're getting the latest versions of the binaries with the latest bells and whistles and with the most recent vulnerabilities hopefully patched. So if you're working in an air gap, you'll have to get permission to download these things from GitHub, maybe burn them to a DVD, and then you can walk them into the air gap. And from there, you can install it inside your machines from inside the air gap. This does not require access to the internet afterwards, and certainly doesn't require access to Microsoft servers. As we were talking about before though, once you're rolling your own, so to speak, and installing the binaries directly from GitHub, that means you're also responsible for patch management too. So as new versions of these binaries are posted to GitHub, it's now our responsibility to get those new binaries, copy them out to our servers and workstations, overwriting the existing binaries that are on the drives. Now, fortunately, this can be scripted out relatively easily with PowerShell. What about the server's configuration? Again, the SSH service does not store its configuration settings in the registry. Those configuration settings are stored in text files on the hard drive. Now, these are stored in files underneath program data whack SSH. Now, program data, that's actually an environmental variable, but on almost all machines where you install the operating system on the C drive, then down at the bottom, the path is C:\program data whack SSH. And for example, the main configuration file for this is sshd _config. That is a text file. It doesn't end with .txt as the file name extension, but nonetheless, that's a text file. So when you're reconfiguring the SSH daemon on your boxes, that's the text file that you are modifying, saving, and then you restart the sshd service. Every time you restart the SSH service on your machine, it rereads that configuration file. So in your labs that are coming up then, you're going to several times modify that file, save the changes, but if you don't restart the SSH service, then your machine doesn't get the changes. It doesn't get it. So again, there are lots of files. Some of them are textual configuration files or key files, and some of them are binaries, like the client binaries or the server binaries. Don't worry, this is all in your manual. So going back to that first reference slide, this was about 15 pages ago. This gives you kind of like an overview of where you find all these files, the kind of file it is, like a text file or a public key or a binary. And then over many pages in your book, it talks about all these files, documents their settings, and so on. I'm mentioning this because I know that you may have taken a course from another training provider where you just have a slide and then maybe a couple sparse notes down at the bottom. That is not how I write my manuals for SANS. All the manuals that I write for SANS are written full like books. I mean, so this section here, this 100-page module, this could be a short book, literally in Amazon. So my hope is that you don't have to take or write any notes at all. So if you have your pen right now and you're furiously scribbling away about where this file is located and what it does and so on, you don't have to. Almost certainly that's somewhere in your notes. We're going to do virtually all these labs in PowerShell Core or in Windows PowerShell. We're not going to use PowerShell ISE. And that's because PowerShell ISE, it looks like a command shell, so this looks like text, but it's more of an illusion. PowerShell ISE is really a graphical app, and the text that you see on the screen, it's not real text actually. So instead, in the lab, we're going to focus on PowerShell Core and Windows PowerShell, the console version. So unless the lab specifically says so, please don't use PowerShell ISE for any of the labs or commands. Now, if you don't have PowerShell core running on your box, no worries. I'll close it. You can easily find it if you click on the Start menu, type in the word PowerShell, and then you'll see PowerShell 7. It doesn't use the word core anymore, but that's what it is. That's PowerShell 7, that's PowerShell core version 7. And then you can right-click, Run as Administrator. Another way that you can launch PowerShell core is you can go to the Start menu, type in the word Run, and then in the Run app, you can execute pwsh.exe. So that's the name of the binary, pwsh. You can also create a shortcut, either on the Start menu or on your desktop, for pwsh. All right, so we're going to do most of the labs in PowerShell core. Some of the labs, you're going to use Windows PowerShell. This is PowerShell.exe. This is also called Windows PowerShell Console. Now, the Windows PowerShell Console looks and behaves like a normal text-oriented command shell. So notice that when I launch Windows PowerShell, that's PowerShell.exe, I don't have menus, toolbar, different tabs. In fact, really, it looks like the old CMD shell, it's just that it's blue instead of black. Now, how can you tell the difference between a PowerShell core and the Windows PowerShell, like during the labs? Notice that in the title bar, it says Windows PowerShell for PowerShell.exe, and it just says PowerShell 7 for PowerShell core. Now, technically, you can also check this out. There's a special built-in variable named PS version table, and that'll also show you whether or not you're running, for example, PowerShell core, that's the PS edition. Whereas if I go back to Windows PowerShell and I type in the same name of that variable, PS version table, notice in this case it says PS edition is desktop, and that tells you that it's Windows PowerShell. In your labs, you're going to be going back and forth between your two virtual machines. So in your lab, in the beginning of a section, it might have the word controller inside of square brackets at the beginning of a section of the lab. And that indicates that you should be in your virtual machine, which is the domain controller. And that machine, by the way, is also named controller. Now, on the other hand, your other virtual machine, this is running server core. This is the box that we're going to SSH into repeatedly. Now, your server core machine, that's a member server that's joined to the domain, and the name of that computer is member. So your domain controller is named controller, that's got the graphical desktop. Your server core box is named member because it's been joined to the domain. It's a member of the domain. And incidentally, the IP addresses of the boxes. Your server core machine is 10.1.1.2, and your domain controller is 10.1.1.1. So just in case there's any issues or you're troubleshooting, then those are the two IP addresses that are involved. All right, so what does SSH look like then? I mean, so we've been talking about it in the abstract quite a bit. What's coming up in your lab? Well, I've just maximized PowerShell core on my screen to make it hopefully a little bit easier to read and see. How's that look on your box? I'm going to right-click on my title bar and go to Properties. And now when I go to Font, I'm going to increase my font size. Feel free to do that on your machine as well. So again, I'm inside of either Windows PowerShell or PowerShell core, totally optional, this is up to you. But if you want to, you can right-click on your title bar, go to Properties, go to the Font tab, and then you can increase the size of the font. So in this case, I'm going to bump mine up to 24 point, but on yours that might be a little bit too large. My two machines are already set up as SSH servers. You're going to do this in the lab in just a moment. So what does it look like when I SSH into another box? Well, for example, I do ssh.exe, or I just do plain SSH. You don't have to type in the .exe actually. And now I want to authenticate as someone who's a member of the testing domain. I want to authenticate as administrator. So this is administrator from the testing domain. It's domain \username. But what is the machine that I'm SSH or connecting into? Well, I type the @ symbol, and then either the IP address, host name, or fully qualified domain name of the other machine. So for example, the fully qualified domain name of my other VM is member.testing.local. Because testing.local is my default domain name, technically I don't have to do that. I can just type in @member. Now when I connect, I'm prompted for my password. And there we go. I've now SSH connected to the remote machine. If I type in hostname, for example, or if I access the hostname or the computer name environmental variable, then I can see that I've SSH to the remote computer. And notice too that on the left-hand side, it shows me the name of the remote computer and also my username. So I type in exit, I disconnect, and I come back to my local machine. All right, so that's like a very basic standard use of SSH. Now the lab that's coming up is quite a long lab, because especially for SSH with all these different binaries and configuration files, in this case, there's no substitute for lots of hands-on experience. So this is quite a long lab. It's on page 90 in your book, page 90. So please turn to page 90. And we have a very long lab. This is quite a long lab, and there's a lot going on here. When I originally wrote this part of the manual, we went through, or at least I was planning on going through several slides talking about all these concepts, and it occurred to me that really, until people get their hands on the machine, it's not going to make that much sense. So instead, I decided that we'd do a big long lab first, and then go back and then review some of the essential ideas together. So I don't know about you, but I don't really feel like I understand something until I get my hands dirty on the product. And there's a lot going on in this last lab. So just to review, I know some people are perhaps still working on the lab, but just to review a few important things. I'm looking at my domain controller VM. I've gone to my local profile folder to the .ssh subdirectory. When I do a dir listing, I see some files. idrsa.pub is a public encryption key file, and I can use that to authenticate to other machines, along with this idrsa, which is a private key file. Now later this week we're going to discuss the difference between a public and a private key. We have a manual coming up later on PKI and certification authorities, but these are keys that we're about to use in another lab very soon for doing key-based authentication instead of password-based authentication. Now, as you saw in the lab, the first time you SSH connected to another machine, you were prompted to confirm the host key. So this is my own personal private-public key pair for me as a user, but machines also have what are called host keys. Now, if I switch over to my other virtual machine, this is the server core box named member. On the server core box, here I am in the program data SSH directory, and when I do a listing, I see first of all the main configuration file ssd_config. That's the main configuration file for the SSH service. But I also see a variety of host keys. Now, host keys identify a machine. The keys that end with .pub, those are public keys, and the ones that don't end with anything, those are private keys. So we have a pair for each type. For example, here's the private-public key pair using RSA flavored public keys. But we have different types of public keys as well. For example, here's an Edwards Curve 25519 public key, and just above it is private key. So when you connect to a machine, the machine will choose one of its public keys to present to you as its identity. And now you're prompted yes or no, is this the machine that you intended to connect to? We're going to see in just a few slides that this is an important issue because users over time will type in yes to confirm anything. And that over the years, if they had prior SSH experience, they've just learned as a habit that whenever you connect and you are prompted, do you want to confirm the key, they just always type in yes. And that opens up the door to man-in-the-middle attacks. So going back to my domain controller then, when I connected to the remote machine and I said, yes, this is the public key, the host key that I was expecting, that key went into a file named known hosts. That's on my local machine, the client machine. So if I do get content and I look at known hosts, then I can see that the name of the remote computer is member. There's its IP address. This is the type of the public key and its host key. And this is the encoded form of the key. Now notice that it begins with, 4 A's and a bunch of gobbledygook and then ends with A0M equals. So if I go back to the other machine, I can tell that this was the key that was sent to me. This is an elliptic curve digital signature algorithm key, ECDSA. And again, we can see it begins with the 4 A's and it ends with AOM equal sign. And if we were to go back and do the work, we would see that this long string right here, the host key on the server, that's what matches this host key in my local known host file. So if I delete that file, and again, this is what we did in the lab, now I'll go back, I SSH back to that machine. Now I'm prompted again. Is this the public key that you were expecting? This is where virtually every user will type in yes, and they won't even read any of the text. So if this is a man-in-the-middle attack going on, I enter yes, I'm now prompted for my password, and when I type in my password, what's happening is I'm giving my password to my adversaries. Because they've now done a man-in-the-middle attack against my session, I've been tricked into entering my password and then giving it to my adversaries. So in just a little bit, we're going to talk about that problem, the problem of managing the known host keys. Something else that we saw in the lab? There's different ways that you can connect to the remote machine. For example, we did this already. I could type in the domain name of my user account, my username, @ and then either just the host name or the fully qualified domain name of the remote machine. And again, notice that I'm now prompted. Is this the machine that you were expecting? I already trusted that key, but with a different name. When I authenticated earlier, when I connected earlier, I connected as member, not member.testing.local. So in this case, I enter yes again. It's been added to my known host key. I enter my password and I authenticate, and now I've connected to that remote box. I type exit, I come back to my local machine. Let's get the contents of my known host file again. And now we can see I have two lines. The first line was for the simple host name or IP address. The next line is for the fully qualified domain name. And in this case, notice that the keys are the same. They begin with, quad A and then end with AOM. Quad A ends with AOM. So it's okay. You can have multiple lines on the known host file for the same machine, and you will have that if you connect using different names, or if you connect using the IP address to that target box. Again, this is going to come up later when we talk about the complexity of managing these known host files. So when I go back, when I authenticated to that machine, I gave the fully qualified domain name, but I could just do the host name. And instead of the backslash, I could use the @ I could also just use the simple username. Now in this case, it assumes, right? So I just authenticated with my password, but who am I? Notice it says member administrator, not testing administrator. Now that's a big difference, because I just authenticated to that target box with a local account at the target machine, not the domain account. So that's the difference. If you SSH to the other box as administrator @member, administrator there, that's the name of a local account. If I want to guarantee that I'm authenticating with my domain account named administrator from the Active Directory domain, that's when I have to put testing / and then the username. And finally, that becomes an issue too if I just do this. If I just SSH to the other box, and again, you don't have to do ssh.exe, just to simplify things, it's just plain old SSH, the member server, I authenticate with my password, But who did I authenticate as? When I run who am I? Interesting. Notice that if you don't provide a username at all, Windows tries to do single sign-on. It tries to authenticate with whoever you're logged on as right now. And because I'm logged on right now with my domain account named administrator in Active Directory, that's why it says testing /administrator. That's why it does not say member /administrator. These might seem like trivial issues, but this is the sort of thing that will drive you insane later on, right? Because you'll authenticate to another box, you know that you logged on as administrator, but things aren't working right. And this could be the issue. It could be that you logged on with the local administrator account instead of the domain administrator account. And one last thing to emphasize. I've come back to my member server. This is the target box. And this was one of the steps in the lab. In the day 2 folder, SSH subdirectory, you can set the default command shell. So when you SSH to a target machine, what command shell do you get? By default, it's the traditional Windows command shell cmd.exe. And if I run this command, that set the registry value to confirm that it's cmd. Now, this particular setting is stored in the registry. It's not stored in a configuration file. But you have a script here for this purpose that'll set that registry value for you. Now, what if I wanted to set it to PowerShell? Again, it sets that exact same registry value, but instead gives the path to PowerShell.exe. That means when I SSH to that target machine, my default command shell is not cmd, it's PowerShell.exe. And finally, what if you wanted PowerShell core? No problem. The last argument you can set here is pwsh for PowerShell core. Now, of course, you have to have PowerShell core already installed at the target machine when you run the command. And the script here, I wrote the script so that whatever version of Windows PowerShell or PowerShell core you have installed, or if you have multiple versions of PowerShell core installed, it'll automatically choose the most recent version that is not a beta. So for example, if you have PowerShell 7.0, that's the final release, and you install, let's say, PowerShell 7.1, that's the preview or beta version, then this little script, it'll prefer the final version, and you'll get PowerShell 7.0. So my thinking is, if you're going to install the SSH daemon on thousands of servers and workstations, then we need to configure this on the boxes. And this is one of the few configuration settings that are stored in the registry as opposed to those textual configuration files. And my hope is that you can use this script then to set whatever default command shell you want on your boxes. And in fact, we have a lab very similar to this coming up on day 6. In the last lab, the client tool that we were using was ssh.exe. Not a lot of PowerShell going on here. I thought the big deal is that PowerShell core was integrated with SSH. Well, on my computer, I've switched back to my member server. This is on PowerShell core. I'm in the folder that contains the keys, the host keys, and the configuration file for the SSH service. Here's another tip, by the way. If you have Visual Studio Code installed, you can type in the word code followed by the name of the file that you want to edit. So I don't have code installed there, but if I go back to my first box, there's Visual Studio Code, I apologize. If I go back to my first virtual machine, I can do code, then the path, in this case is program files, program data, SSH, and again, the name of the main configuration file, ssd_config. So normally we type ISE followed by the path and it opens up in an editor. But if you have Visual Studio Code installed and you would like to do that, then you can open up this way too. I've configured both of my machines for PowerShell integration. And that means I've edited this file, ssd_config, to include this line right here. There's the keyword subsystem, associated with an alias, PowerShell, and then the command associated with that alias. Now what this means is that when I use a PowerShell commandlet like invoke command or enter PS session, when those tools connect to another machine, they send through a subsystem command, and that command is the word PowerShell. And on the remote or target machine, that means this associated command is automatically executed. Now notice in this case, the command that I'm running is PowerShell core. I don't want the logo or copyright information. I don't want to load or run any PowerShell profile scripts. But then there's this last switch here, SSHS. That's for the PowerShell subsystem. What that means is, we are launching PowerShell core on the remote machine in a special way. Namely, in a way that executes commands that produce objects, where the objects are automatically converted to XML, sent back over the SSH connection back to the client side, the machine where I'm sitting, and then the XML is converted back into objects again. Now, that's where the PowerShell core integration comes in. It comes in here when you can add this special line. It's a subsystem keyword. You have to use the word PowerShell in lowercase, followed then by whatever command you want automatically executed. And in this case, it's got to be PowerShell core with these special command line switches. Now, what's the difference then? I'll close that. I go back out. Now again, I'm sitting at my client machine. That's what I should have connected to begin with. On my client machine, but I'm connecting outbound now to my member server. And on my member server, I've already made that same change to the SSD config file. Now, instead of using SSH directly, I'm going to do this. I'm going to do invoke command. I now give the host name of the remote computer, not computer name. We're going to see that's important in just a second. Give the name of the target machine, and then for my script block, whatever command it is that I want to run. Like, for example, maybe I'll run the command get alias. That returns objects then that represent your aliases. I'm now prompted for a password just like before. And we can see that this is the administrator account from the testing domain. So I type in my password and authenticate. At the remote machine, what has happened is that the PowerShell daemon at the remote machine has launched PowerShell core with that -SSHS switch. I sent my command in the script block to the remote machine. It ran get alias, but the output of that command was converted to XML, returned back to my local machine where I'm sitting, where the XML data was converted back into normal PowerShell objects again. So notice, what do I have inside the X variable? I know that it looks like text here on the screen, but it's not. The X variable contains an array of objects, in this case alias objects. And because these are true objects, I can do things like this. I can get the first object from the array using an index number because it is an array. Again, it's not text. And for example, I have properties like, for example, the name property. Or how about the command type property? So notice above, the X array is indeed a true array. It's not just a big pile of text that I have to parse. So the first object in the array is an alias object that has properties. We can see that one property is command type. What kind of command is it? It's an alias. And that means I can use the period here to denote either a property or a method. I've gotten back a property bag, an object with a bunch of properties. It doesn't have any methods, but at least I have the properties here. Now this is where the PowerShell core integration comes in. When you just use enter PS session or SSH and you connect to the remote machine, yes, the traffic is all SSH encrypted, but in a sense, the data is trapped at the remote box. And you're just consuming the output of the commands with your eyeballs, so to speak, as the text is scrolling by. But on the other hand, when I use invoke command, like I did a second ago, when I use invoke command, the output of that command on the remote machine is converted to XML, sent back to me. I convert them back into objects. I don't get back a bunch of text. I get back real objects with real named properties. And I can now manipulate that array of objects and access their properties by name. So going back to the slide then, at the target machine, you have to install PowerShell Core. It can't be Windows PowerShell. It's got to be PowerShell Core. And then you edit the sshd config file at the remote machine to include that line that says subsystem, followed by the word PowerShell, followed by the command that you want executed. And again, when is that command executed? It's when you use the invoke command, right? So when you use invoke command, you're connecting to the remote machine, you're executing a command, but you want the objects returned to you, not the raw text. There's another subtle difference here. I mentioned it very briefly, but it makes a big difference. We saw invoke command earlier today. But earlier today, when we connected to a remote machine, we connected with the -computer name parameter. Now, on the other hand, when you want to connect and use SSH and talk to the so-called SSH subsystem for PowerShell at the remote machine, you don't use -computer name, you use -host name. It's a subtle difference. It's so easy to forget this. But when you connect with -computer name, you're going to use the WSMAN protocol to talk to the WinRM service. But when you use the -host name parameter, you're going to use the SSH protocol and talk to the SSH daemon on the remote machine. So the computer name parameter is for WSMAN and the WinRM service, traditional remoting. The host name parameter, that's for the SSH protocol to talk to the SSH daemon. And again, what are we getting back from that remote machine? We're not getting a big glob of text that we now have to parse and slice and dice. We're getting back objects with named properties. And that's how we can do commands like as shown in the slide here. In the slide here, it's showing that I'm running PS inside the script block on the remote machine. And what I get back are process objects. And so they have properties like name, ID, and path. In other words, we get good, well-behaved PowerShell objects. In the next lab, we're not going to edit that file by hand because that's not DevOps. Instead, I have a script for you that'll edit the file for you, and it'll use the latest version of PowerShell Core that you have installed on your box. In your manual, please go to page 102 for the lab, and then we're going to set up PowerShell Core as a so-called SSH subsystem. We've gone through a couple long SSH labs now, and you might be getting tired of typing in your password over and over and over again. Watch this. I've just switched over to my domain controller, and I've made a change. Now the change that I've made is this. I'm going to SSH to the remote machine, and notice, I was not prompted for a password, but I was still authenticated. If I do who am I, or if I look at my command prompt, we can see I did log on as administrator from the testing domain. But how did I authenticate if I wasn't prompted for a password? You can authenticate with public-private key pairs. So we've been authenticating over and over and over again with a password, and that gets a little bit tiring. But you know, it's also a bit risky because every time you enter your password, there can be a keystroke logger. If it's a short, weak password, then your adversaries might be able to brute force guess it as they simply, bomb your target machine with millions of SSH authentication attempts as they attempt millions of different passwords. And if you use a decent passphrase, and you have to authenticate over and over again, well, it does get a little bit tiring. Now, on the other hand, with key-based authentication, step one, you're going to do this in the lab in just a moment, you run a tool named SSH keygen. That will generate a public-private key pair. It'll save the public-private keys as two files, a public key file and a private key file, and it goes into your local profile folder. Let's take a look. I've gone back to my machine. This is my domain controller. I do a dir listing, and I can see that I already have a couple key files here. The .pub file, that's for the public key, and the file with no file name extension, that's the private key. Now, how did I create this? I used the SSH keygen tool. There's different types of keys that you can create. So if you use the -T switch, you can specify different types of keys, like for example, an Edwards curve 25519. It's just a different flavor of public key. I've already got an RSA public key, so now I'm going to create another one. Now it prompts me for the path for saving the key files. Notice that the default path is what I want. It's in the users administrator folder, that's my local profile folder. .ssh, that's where I want the keys to go, and the name of the file is id_ed25519. If you are happy with the default, just hit enter. Now, what about the passphrase? If you enter a passphrase here, it encrypts the private key with the passphrase. But if I simply hit enter twice in a row, the private key is now in plain text on my hard drive. There is no encryption passphrase. And that means when I use that private key, I'm not prompted for the passphrase. So if you do enter a passphrase, then, well, you've got a password to enter now, right? Just like before. But now in this case, that's not a password for authenticating to the remote machine. That's a password for decrypting access to your private key file. In this case, I just simply hit enter twice in a row, no password configured, the private key is in plain text. It now shows me the fingerprint, in this case is SHA-256, and it shows the fingerprint in an encoded form and the associated identity. So like if you're authenticating over the phone with someone, you could say, well, here's my fingerprint, and we're also going to see that that fingerprint will go in a special file. Keys can also be identified by what are called random art images. This weird-looking picture is almost uniquely associated with my Edwards 25519 key. This is generated by having, the algorithm is actually pretty interesting. It's generated by having like a little virtual character walk around a garden, picking up and dropping things. And what you see inside this little random art image is kind of like an abstract representation of the path as that person walked around inside the garden and picked up and dropped things. The important thing is this. That is almost uniquely associated with my key pair. So when I authenticate to others, they can look at my random art of my keys, and when I'm authenticating a server with its host key, I can choose to display that random art image. It's not actually required, and most people just totally ignore these things, but the thought process is that over time, as you authenticate to other machines over and over again, and you display the random art of the public key on the other box, then over time you'll come to expect to see a particular image. And if all of a sudden you see a different image, well then that's supposed to get your attention, and then maybe you won't authenticate. Maybe you'll contact the help desk. Mostly it's kind of for fun, but it's not absolutely required. It's nice, but again, not required. But now that I've generated these keys then, if I do a dir listing, I can see that I have my new Edwards curve 25519 public-private key pair, as well as my original one. I now switch over to my other virtual machine. This is the server core box. And on the other VM, notice that I've gone to my local profile folder, and something I want to point out, this is going to be important in just a moment. On the remote computer, the name of my profile folder is not administrator, it's administrator.testing. Now that's going to be important because you have to know the name of the folder of the profile of the user account, because you have to create a special file in that profile folder. So again, I know this seems trivial right now, but in your lab it's not going to be trivial. Over here on the left, this is my domain controller, and the name of my local profile folder is just administrator. But on the member server, the name of the profile folder is administrator.testing. Now, why does that make a difference? I did a dir listing in this folder, and notice I've got a file named authorized keys. I'm going to do get content and read the contents of that file. Now, this looks like a long string of gobbledygook, but this is a representation of my RSA public key. So going back to my first computer, I already had an RSA private key and my RSA public key. Now these things, depending on how it's hashed and displayed, they don't always display it in the exact same way, but nonetheless, I do get content of my RSA public key on the machine where I'm sitting. This is the client device. And notice that this long string, quickly memorize that if you would. Memorize that long string so that now when you go to the server core box, a copy of that public key of mine has been put into the authorized keys file in my profile folder at the target computer. Now, again, I know this is a giant ton of acronyms and weird configuration files, but the short of it is this. The public key on my client computer has been copied to the target machine and associated with my user account. And the way that you associate your public key with your user account on a remote machine is to put that public key into a file named authorized keys, and that file has to go into the .ssh folder, and that has to be a folder in your local profile folder at the remote machine. Now, why go through all this effort? Why would I do all this work? It's because of this again. I do SSH, I give the name of the remote machine, and notice, bang, I'm in. I authenticated, not with a password, but with my public-private key pair. With my private key, I was able to authenticate against the public key on the remote machine because the authentication was successful, because I proved to the SSH daemon on the other box that I have the corresponding private key. Then the SSH daemon on the other box, it looked through all the local profile folders on the machine, looked in the SSH subdirectory in all those profile folders, and it found all the authorized keys files that might exist. It then searched all those authorized keys files to see if there were a matching authorized key for the one that was used to authenticate to the box. And because there was, the SSH daemon magically logged me on. The SSH daemon is running under system identity. It has full operating system privileges. So it has the power to allow me to log on over SSH using any decision criteria it cares to follow. And in this case, the decision logic or the criteria that it's using is, if I can prove to the SSH daemon on the other machine that I've got the corresponding private key, then the public key is associated with the user account, and the SSH daemon will just magically log me on as that user account. I'm not prompted for a password. So that means you can authenticate with a public-private key pair, but to set this up, you have to copy your public key to the remote machine, put that key into the file named authorized keys, and that's got to go into your local profile folder at the remote box. Now the SSH daemon service, it'll find it and magically log you on to the target, and you don't have to type in your password. So in step number 1, I generated a public-private key pair. In step number 2, which I didn't show, I did this earlier, I copied my public key into the authorized keys file on the remote machine, but that has to go specifically into my local profile folder. Now, something else that I did earlier too, you're going to do this in your lab in just a second. I had to modify the server's sshd config file. So I go back to that server. It's in program data, SSH, name of the file, sshd config. So I'm going to open up a notepad on server core. I did have to make a change. If I scroll down a little bit, notice that public key authentication is enabled by default. I know that this is commented out, but that's all right. Yes means that it's enabled by default. But the reason I had to edit the file was this down at the bottom. It's these 2 lines. By default, these 2 lines are not commented out. And the effect of these 2 lines is I have to be a member of the administrators group, and my public key has to be somewhere else. Now, we're going to talk about those 2 lines in just a few slides, and we have a little lab on this coming up, but just be aware that To set this up and make the lab work, you do have to comment those lines, and then you have to restart the service, the sshd daemon service. Now, once I've done all this, I can now SSH remote into the other machine. I'm not prompted for a password. My private key is associated with my public key, and my public key has been copied to that machine into the authorized keys file. Again, if you're new to SSH, and I assume most of you are, then there's all these gears and cogs, all these moving parts. And stepping back for just a second now, this means that we're in some ways bypassing normal Windows authentication controls here. We're not using Kerberos. In some ways, we're not even really talking to the operating system to authenticate to the target machine. Really, I'm talking to the SSH daemon at the target machine. And because I have a private key that corresponds to a public key in the authorized keys file, it's the SSH daemon using its system privileges. It just magically logs me on. It's almost like doing an end run around the Windows bureaucracy. It's almost like ignoring normal Windows authentication restrictions and controls. Now think of this from a hacker's perspective. If a hacker can steal my private key files, like these two files right here, then the hacker can authenticate as me to other boxes. The hacker doesn't have to know my password. The hacker just has to get these files. Now, those files might have passwords for encrypting the private key data, but if it's a short, weak password, my adversary is going to run it through a brute force cracker application, let it chew on that for, let's say, a month, and then they figure out my password, and now they got the plaintext private key file. And with that private key file, my adversaries can now authenticate as me to other boxes. Ah, but which other boxes? I go back to the server core machine again. On the server core machine, I do a dir listing. This is in my local profile folder on server core. Hackers who have stolen my private keys can authenticate as me only to other machines that have this authorized key file. And again, that authorized key file has to have one of my public keys in it, and that file has to be located here in my local profile folder. So we got to protect those private key files. Now, let's attack it from the other direction. What if I'm a hacker? I've generated my own public-private key files, and I append my own public key to this file, the authorized key file. So if I can append my own hacker public key to that file, authorized keys, then I can log on as you with your authorized keys file. Because as an attacker, I've generated a public-private key pair, maybe because I couldn't steal your private key for some reason. So I generated my own public-private key pair. I append my own public key to this, the authorized keys file, in your profile folder. And that means I can authenticate as you to this machine, and I don't have to know your password. So not only do we have to protect the private key files on our workstations, we also have to protect the authorized keys files at the target machines. Because if your adversaries, like with malware, if your adversaries append more public keys to this file, the authorized keys file, then your adversaries can authenticate and log on as you, and they don't have to know your password. So again, that's that double-edged sword issue. It's very convenient, and there's many security benefits to doing key-based authentication. But on the downside, if my adversaries steal the private keys, or if my adversaries can append their own public keys to that authorized keys file, then that can cause massive problems. I don't know if you recall, but when we ran the script to install SSH, it installed the SSH daemon, the service, but it installed another service called the SSH agent service. Now, the SSH agent service runs on both the machine where you are sitting and typically at the target machine that you connect to. The SSH agent service gets your private keys, encrypts them in memory and on the hard drive, and helps to protect your private keys for you. Now, the nice thing about this service is that when I authenticate to another machine, and I need to use my private key to authenticate to the other box, it's actually the SSH agent service that does the authentication for me. In a sense, I'm no longer protecting my private key files myself, like with permissions on the hard drive or some other tools. In a sense, I'm outsourcing that work. I'm giving my SSH private keys to the SSH agent service running on my box. It's up to the agent service then to encrypt those keys in memory and encrypt those keys on the hard drive. Now in Windows, how's this done? It's done through DPAPI. DPAPI, the acronym, stands for the Data Protection API. Now this is a feature of the Windows operating system for encrypting secrets so that only you can access your encrypted secrets and nobody else. For example, if you have cached passwords in Internet Explorer or in Microsoft Edge, then what encrypts those cached passwords is it's DPAPI, this feature of the operating system. It's actually not the browser. Or what if you have like an email certificate? You have an email certificate and the private key for that email certificate. What protects the private key for that email certificate? Again, it's DPAPI, this built-in feature of the operating system. So in Windows then, we can give our private keys to the SSH agent service and let it take care of the private keys instead of us trying to protect it ourselves. There's another benefit to this as well. What if I'm sitting at my workstation and I SSH to a jump server? The jump server also runs the SSH agent service. And I go through the jump server and I connect to a third machine, like a web server inside the LAN. Now that web server requires, let's assume, key-based authentication for SSH. So I'm going from my workstation to the jump server to the web server. I don't want to expose my private key to any other box. So what happens is that third machine, the web server that I'm talking to, it sends the request for authentication to the jump server. The agent service on the jump server relays that request back to me and the agent service on my workstation. Now, the private key on my workstation never leaves my workstation. It's able to encrypt and decrypt the necessary data with my private key, which is then sent back to the jump server. The jump server then relays it to the third machine, the web server, and I'm able to SSH and log on to that web server then. And notice that I didn't have to expose my private key to any other box, not to the jump server and not to the third machine either. That's another one of the benefits of having this agent service. So the two main benefits of the SSH agent service is, first of all, I can give it my private keys and let the agent service protect the keys for me. And then second, the agent service acts as my agent, as a relay agent. And that service can relay authentication requests through jump servers to other machines. So, a very nice feature. Now, how do I give my private keys to the SSH agent service? Well, there's a tool for this called sshd. If I do -L, it'll say the agent has none of my identities. In other words, it doesn't have any of my private keys. Now, if I run just SSH by itself, it found my two private keys, my RSA private key and my Edwards 255.19 key, and those now have been given over to the SSH agent. So when I run sshd -L for list, then the SSH agent says, hey, well, these are the two private keys that I have for you. On my local drive, I can now do this. I can do move item. The path here is, how about ID star. I'm going to move all of these files, and I'm going to put them into the temp folder. So when I do a dir listing, I don't have any public or private keys here at all. But watch, when I do SSH, let me clear my screen so you can see it better. When I do SSH member server, was I prompted for a password? No. It was key-based authentication. But not keys that I have here in my SSH folder. I moved all of them. My client tools can't find them. But that's okay because it's the SSH agent running on my box that has my private keys. Now watch this. If I do SSH add -D, that removes all of my identities, all of my private keys from the care and protection of the SSH agent service. When I try to list them, it doesn't have my private keys anymore. So what happens when I SSH back to the member server again? I'm prompted for a password. I can't authenticate with a key because I moved my keys to another folder. My client can't find them. And I removed those keys from the protection of the SSH agent service. And that's why I'm being prompted for a password. If password authentication were disabled at the remote machine, I wouldn't even be prompted for a password. I would just get an error message. And of course, the recommendation for security is turn off password authentication. So in this case, I type in my password like usual. I've now authenticated, but not with my private key, but with my password. Since I'm back on my local computer again, if I do move item, and the path in this case is the temp folder, all the files that begin with ID, destination is going to be my local profile folder, SSH subdirectory. Now I've moved those key files back again. Now when I SSH to the remote machine, it's going to find that key file on the hard drive. It found my private key file on the hard drive, and that's how I was able to authenticate and not be prompted for a password. So right now, it's not in the care and protection of the SSH agent service. We can tell that because when I try to list, it says I have no identities for you. But if I run that tool with no command line switches, I've now given my private keys again back to the SSH agent service. So that means I could authenticate either with the private key on my hard drive or with the private key that I've given to the SSH agent service. So in setting this all up, step number 4 then would be to run SSH add to give copies of your private keys to the agent service. And then step number 5, we would make backup copies of my public and private key files, and then I would delete those files from my machine. Remember, hackers want to steal my private key files. So if I delete them after making a backup, it's going to be more difficult for my adversaries to steal them. This slide gives an overview then of the necessary steps, and that's what we're going to do in the lab. So that's like another review or cheat sheet slide to see how all the pieces work together. But I think in this case, again, getting our hands on it is the best way to learn. In your manual then, please go to page 117 for the lab. All right, so in the lab, we got a taste of using the SSH agent to protect our private keys and to authenticate on our behalf. And the huge advantage is we don't have to type in a password over and over and over again. Now, speaking of passwords, there's many other things to which we have to authenticate that still require passwords. Think of all the websites, for example, that you visit on a regular basis. So there's a good chance that you already have a password manager application for managing your passwords for all those other things that require passwords. Well, if you're doing this, then you might prefer to use a password manager app that can also secure your SSH private keys. So in the last lab then, we were using the SSH agent to secure private keys. But there is another way of doing it. You can use a password manager like KeePass, for example. That's just an example. But with KeePass, I launch my password manager application. I might type in my passphrase or use my YubiKey to unlock the little database of passwords. Now, when I unlock it, the password manager talks to the SSH agent, or the password manager acts as the SSH agent itself. So imagine that you have a password manager that knows how to add and remove keys from the SSH agent on your machine. So every time you launch the password manager, you type in your passphrase, you have access to all your passwords, but also it gives your private keys to the SSH agent. And then now when you close or lock your password manager app, before it closes down, it then removes the private keys from the SSH agent. Now, how is your password manager app protecting your private keys? They're not on your hard drive. The private keys are encrypted in the password manager's database along with all of your other passwords. So if you are using a password manager application like this, and I bet you are, then maybe you could get two birds with one stone here and have it protect your private keys for SSH as well. My own personal preference is for KeePass, but in your manual you have a listing of over a half dozen of the more popular password manager tools. There's also a list of best practices for securing password managers in general, and then a second list of best practices specifically for KeePass. KeePass can talk to your SSH agent, but also KeePass itself is PowerShell scriptable. So your PowerShell scripts can directly mount your KeePass database and read and add or update the passwords in that database. And you don't have to use the graphical interface for the KeePass manager. It can actually all be done in PowerShell. In fact, you can even put encrypted PowerShell scripts into the password manager database when you're using KeePass. And you can launch and run those scripts directly from the encrypted password manager. So you've probably heard 1,000 times, never ever hard code passwords or other secrets into your scripts. Well, that recommendation assumes that your scripts are in plain text on the hard drive. But if the script instead is encrypted inside the password manager and is launched from the password manager, well then maybe it's not so bad if you hard code some of those secrets. All right, so this is just a tip to make it more convenient and more secure in handling your private keys. You can have your password manager app help you to do this work. So after these last couple labs in particular, if we step back and think about the enterprise, think of the problem that we face now. Hosts generate host keys, and those should be rotated like maybe every 3 to 12 months. And of course, if there's a compromise, they have to be rotated immediately. Users will have their own keys, and those should be rotated perhaps even more often because the user keys are even more likely to be lost or stolen. So users might generate new keys every 3 to 6 months. But then there's also the authorized keys files on all the target machines to which we are authenticating. We also have the known hosts file that contains the host keys of the other machines to which we are connecting as well. And if we don't take care of that, then we open up the door to man-in-the-middle attacks. So when you hear from other people that SSH is easy to use and easy to manage, ask them about the details. Are they rotating keys? Are they only using SSH on a small handful of servers? Well, our goal is to use SSH across thousands of servers and workstations. And this potentially can become a complexity explosion. It can be unmanageable. There's a NIST report number 7966 that talks about exactly this issue. And this is a quote, there's a quote in your manual, not the slide, a quote in the manual directly from that report talking about how enterprise key management can become a nightmare. The quote is in your book on page 134. It says, the sheer number of SSH keys and the complexity of resulting trust relationships makes effective management via manual processes nearly impossible. We have to do as much of the management in an automated way, using things like PowerShell, group policy, or enterprise management tools like System Center. So what can we do then to try to tame this complexity explosion? If you're just going to use SSH on, let's say, like a dozen servers and a few workstations, well, yes, that can be done by hand. But once we start scaling this out to the enterprise, it becomes a real management problem. Imagine that we delete every authorized keys file that we find throughout the entire organization, so that nobody, at least right now, can authenticate with their keys to other boxes. Now, instead of each user having their own separate authorized keys file, what if the machine had a central global authorized key file? Now we have one place that we could examine and audit. one place to manage keys. So in the sshd config file, that's the main configuration file for the SSH daemon, you can add these lines to the bottom of that text file. Match group administrators. That means when somebody authenticates, they have to be a member of the administrators group, and their public key must be in the centralized authorized keys file. So there you can see the keyword authorized keys file, and that'd be followed by the path to one centralized authorized keys file. So instead of having, let's say, 20 separate authorized keys files for 20 separate users on the machine, there's one central file, and then everybody's public key is added to that. So in this case, we have two restrictions here. First, you have to be a member of the administrators group, and second, your public key has to be in the centralized authorized keys file. You could even have multiple lines like this in this configuration file, sshd config. As you can see at the bottom, I've got another match group entry. Now in this case, it says match group testing whack domain admins. Because of the space character, it has to have double quotes. And by the way, there is a reason that these lines, these group names are in lowercase. Microsoft recommends that they be in lowercase. So in this case, you have to be a member of either the administrators group or the domain admins group. But whichever group you are a member of, well then the authorized keys file must contain your public key. These authorized key files, you could have two separate authorized keys files or one authorized keys file, and then both of the groups reference that one file. So on the slide here, it's referring to the local administrators group and also the domain admins group in Active Directory, but both of them could use one shared authorized keys file. So that means, as far as the access control rule goes, when you authenticate to the machine, you have to be a member of either administrators or domain admins. You don't have to be a member of both. You have to be a member of at least one. And your public key has to be in the authorized keys file. So if you are an auditor, you've got one place to look. It's the sshd config file. You can see all the list of groups who are authorized to connect and authenticate with a key. And you've got one authorized keys file. The comments that we saw in the last lab can be added to these files, to the keys, to help to identify them. And we can extract usernames associated with the keys from that authorized keys file. So from this perspective of like an auditor, incident handler, or a threat hunter, this now becomes a much more manageable problem. We can centrally control this, both a centralized authorized keys file and also the sshd config file, one location with a list of all the groups who are permitted to SSH in, and you have to be a member of at least one of these groups. Now, how do we configure this? How do we configure our machine to use a centralized authorized keys file? Let's give it a shot. Better to do it than to talk about it. So please turn to the next lab in your manual. This lab is on page 138, page 138. So in the lab, you're going to configure the sshd config file. We're going to configure the match group lines and specify which groups are permitted to SSH into the machine. And then we're going to add our own key to the centralized authorized keys file instead of having a bunch of scattered separate authorized keys files. So the problem that we're tackling right now is this complexity explosion. We're managing host keys, user keys, authorized keys files, known hosts. Wouldn't it be nice if we could use a centralized authentication database, which is authenticating machines and users, and that is compatible with single sign-on? And in fact, we can do it. OpenSSH on Windows and Linux too, but specifically about Windows, OpenSSH on Windows supports Kerberos, the same protocol that we use for mapping drive letters, RPC connections, and for almost everything else that we do in an Active Directory environment. So the whole point of having Active Directory is to have a centralized authentication provider that supports single sign-on in a scalable way. And we are already totally dependent on Kerberos inside the LAN. Now, going over the internet, on the other hand, we can't use Kerberos over the internet because we would never expose our domain controllers to the internet for the sake of giving tickets. If you are going over the internet, well then we are back to key-based authentication. But inside the LAN though, if we want to use SSH across thousands of workstations and domain joined servers, Kerberos is pretty nice. This requires OpenSSH 8.0 or later. In other words, you're getting it most likely from GitHub. Both machines must be joined to the same domain or at least trusted domains. And you have to be able to talk to a domain controller to get your Kerberos tickets. So again, we're not using this over the internet. If you're not sure exactly what versions of the SSH client or server tools you have on a machine, then you have a script on your flash drive called show version OpenSSH that'll find your SSH binaries and show you the versions. To enable all this, you edit once again the sshd config file for the SSH service. And we have to make sure that there's a line that says GSS API authentication, yes. GSS API is a generic multi-purpose authentication interface. And in this case, it's an authentication interface for accessing the Kerberos libraries, specifically on Windows, using what's called the Kerberos or Negotiate Security Support Provider. In other words, you have to set this line in the file and then restart the service. Now that's on the server side, assuming that the machine is joined to the domain and meets the other requirements. Now on the client side, how do you connect and then use Kerberos? It's with the uppercase K command line switch. Using uppercase K, you'll use a Kerberos ticket to authenticate to the remote machine, the same Kerberos tickets that you get when you log on, and access other boxes over the network. If you would like to use Kerberos by default for all the machines inside the LAN, you can create a file named config. So no .txt extension, just the name of the file is just config, and notice that it goes into your local profile folder. If you create that file, you could set up a wildcard like, star.testing.local, so that any machine that ends with testing.local, you'll automatically attempt to use Kerberos when you authenticate to that box. So that way, if you do create that textual configuration file with the necessary lines, this is all in your manual. You don't have to try to research it. It's all in your manual. In that case, you don't have to use the -K switch. If you are connecting to a machine inside the LAN, you'll just automatically attempt to use Kerberos. But if you're connecting to machines outside the local LAN, well then you'll use either a public-private key pair or perhaps a password. So this can help us to tame the complexity explosion even more, especially like on your workstations. That's another policy you could implement. You might say, well, whenever I'm SSH connecting into my workstations inside the LAN, all those machines are joined to the domain, I'm just going to use Kerberos. But when I'm connecting to my servers, many of which are in the cloud or in the DMZ, when I connect to servers, I prefer to use key-based authentication. And of course, you can mix and match these policies as you wish. Please turn to the next lab in your book. In your lab then, we're going to edit that sshd config file, enable support for Kerberos. You could do something similar on Linux machines that are joined to your domain as well, but that's not in the lab. And then you're going to authenticate with Kerberos. There's really nothing to see here when you authenticate with Kerberos, and that's really kind of the point. You're not prompted for a password, but you're also not using public-private key pairs. You're just using Kerberos, just like when you map a drive letter. Kerberos, by the way, you have to present your identity in a form that Kerberos likes. So if you're familiar with UPNs, user principal names, so when you connect and you get an error message, you might connect again, but not specifying a username at all, or specifying just a plain username, or domain/username, or you can use the full UPN syntax, which is user@host, and then a second @ symbol for the host again. There's some other tricks that we can do. In your manual, if you take a look at page 149, you can use something called force command. So what if I modify my sshd config file? So I do match group administrators, permit TTY no. TTY stands for teletype. And permit TTY no means don't allow an interactive command shell. And instead, when you connect and you're a member of the administrators group, execute the following force command, return the output of that command, and immediately exit. So you don't get a command shell, you get a hard-coded command. So let's say I remote in, I'm a member of the administrators group. At the remote machine, it executes PowerShell.exe followed by the path to the script. That script executes. The output of that script is sent back to the user, but then the SSH connection immediately disconnects. You don't get an interactive command shell. Now this might be more useful instead of for an entire group. This might be useful for an individual user. In fact, maybe a user account created specifically for this purpose. So down at the bottom it says match user. Now in this case, it's Amy from the testing domain. Now that could be for a real normal human user, but that could also be a designated account that is only used for this purpose, for the force command. So you authenticate as Amy, you don't get a command shell, permit TTY is set to no, and instead, in this case, we're running PowerShell core, executing a script, and the output of that script is then returned back to the user. Well, this is like a hard-coded command instead of allowing the user or the attacker to choose the command. So we choose the process, the script, and the command line arguments that are passed into that script when it's executed. So it's hard-coded, it's baked in, and it might be a way to allow regular users to execute a PowerShell script with elevated privileges. Because in this case, that user Amy might not be for a regular user. That could be a designated account for just that purpose. And the Amy account could be added to the administrators group on the machine, which means that the PowerShell script runs as administrator, but you don't get an interactive command shell. You get the force command, and then that is it. So you can associate a force command with an entire group, but in real life, it's probably more likely that you'll create a special user account just for this purpose, like for example, the Amy account, and then have an associated hard-coded command for it. There's many other keywords that we can use as well. These are just a sample of the types of keywords that you can add to the sshd config file. It's a nice trick. Here's some more keywords that you can add to that file. Keywords like deny users and allow users. Exactly who is permitted to SSH connect into a machine? Well, by default, it's anybody who can authenticate successfully and has the necessary logon right in Windows. But the SSH daemon itself is able to accept and deny people based on their usernames, IP addresses, and group memberships. If you have all four of these lines in the sshd config file, this is the order in which they are processed, by the way. As soon as there's a match, then the connection is either denied or allowed. So for example, at the very top here, notice that we are denying the guest account. Even if you authenticate successfully as guest, you can't SSH in. We're also denying Alice from the testing domain and Bob from the testing domain if Bob's source IP address is 10.666. So notice the syntax here at the very end. Not only do you have to authenticate as Bob to be denied, but you have to be coming from a source IP address of 10.666. The IP address is not required. And instead of specifying a specific full IP address, you can use wildcards. So for example, take a look at the second line. For allow users, we're allowing username Kate, that's a local user. We're allowing username Brady from the testing domain, but only when Brady's source IP address begins with 10.4.3. Now a single question mark, that represents a single character. So that would match like 10.4.3.1, but would not match 10.4.3.11. If you want to match multiple characters, then you have to use the star, the asterisk. And for example, notice what we have at the very end then. It says testing \**. Now that'll match any user from the testing domain. Now what about for groups? As you can see down on the third line, we're denying the guest group and the domain admins group, but only when you are a member of the domain admins and you are coming from a source IP address that begins with 10.4.9. And then for the allow groups at the bottom, again, we're allowing the auditor's local group and the Boston admins global group from the testing domain, but only if you are coming from, you're a member of the Boston admins group, only if you are coming from a source IP address that begins with 10.4. Notice that you can use multiple wildcards separated by the periods. So imagine that the Boston admins have jump servers and administrative workstations, and we have set aside a range of IP addresses for the Boston admins. They all begin with 10.4. So in this case, you have to be a member of the Boston admins group, and also you have to be coming from one of the known source IP addresses for the jump servers or workstations of the Boston admins. Now, in the sshd config file, you don't have to have all 4 lines. You could have between 0 and 4 of these lines. But as shown on the slide, this is the order in which these lines are evaluated. As soon as your user account, or as soon as one of your groups matches a line, that's the line that determines what happens to you. So for example, if you are denied access, you are denied, end of story, even though you might be a member of a group which is allowed access at the bottom. So for example, if you're a member of the domain admins group and you're coming from the 1049 subnet, well, you're going to be denied access, even though you might also be a member of the auditors group. As you can see on the last line, the auditors group is allowed, but it doesn't matter, because once one of the prior lines matches your user account or one of your group memberships, well, then it's that prior line that determines what happens to you. So this is very nice, to be able to combine group memberships with source IP addresses. Very nice, especially when we consider things like jump servers and admin workstations. We want to keep track of everyone who's logging on to the machine. So the SSH service writes to the Windows event log by default. And you can see on the left-hand side in the slide where that Windows event log is. It's a special log just for OpenSSH. Now, what if you would prefer to write to a textual log file? Now, in that case, you would again edit the sshd config file, and you would set or uncomment syslog facility local 0. Now, once you have that line and you restart the service, the SSH service no longer writes to the Windows event log, and instead it writes to a textual log file on the hard drive. So your choice, Windows event log or the textual log, but you can't write to both. The textual log file is located underneath the program data, SSH, logs subdirectory. And the name of that file is sshd.log, just a normal textual log file, very similar to a syslog that you would have on a Linux machine. If you want to add verbose information, you can also set log level debug in the sshd config file. And in this case, you'll get not just normal things like logons, but also lots of low-level debugging information. You might use this temporarily, like for incident response or forensics, but otherwise it's going to fill your logs with tons of data. From the client side, when you're troubleshooting, by the way, notice that you can connect with between 1 and 3 V switches. So in this case, is triple verbose. You can also combine the V switches. You can do -VVV, and that'll give you triple verbose debugging information on the client side. So we can debug problems or do like forensics analysis on the server side by examining its logs. That's the most important side. But on the client side, when you're troubleshooting, you can add -VVV and get lots and lots of information as you are connecting. For example, it'll tell you why the connection is failing. So for example, if let's say Kerberos authentication is failing, then you could try to connect again with -K and then -V or maybe multiple -v's, and then we could start looking through the output to see exactly where the authentication is failing. Keep in mind that when you authenticate using SSH, with or without PowerShell, you are logging on with a Windows user account, and these are considered network logons, type 3 logons. So OpenSSH has its own separate log or its own textual log file, but when you authenticate with a Windows user account, you can also look in the security event log, the normal Windows security event log, for network logon type 3. That corresponds to event ID 4624. This means that SSH logons are also governed by the network logon right. Now, we're going to talk about network logon rights later on in this week, but this is indirectly another way that you can control who is permitted to SSH into your boxes. So if I lack the network logon right to a machine, I can't log on over the network using any protocol, including SSH. This is important not just for logging, by the way. There's another issue. When I authenticate with passwords, the SSH service obtains a special Kerberos ticket for me called a ticket granting ticket. Now again, I'm authenticating with a password. Obtaining the ticket granting ticket, that's occurring not on my machine, but at the SSH server. Now that's important because now, if I go through the SSH server as a jump server, I could then use Kerberos to authenticate to other boxes. Now, ironically, what if I do authenticate to the jump server using Kerberos or with a public-private key pair? Now, under this circumstance, the SSH server does not obtain a Kerberos ticket granting ticket for me. This causes problems, because if I'm using that as a jump server, I now have the dreaded second hop problem. Now, you may have run across the dreaded second hop problem in other, using other applications or other protocols, and it applies to SSH too. Because a very common use for SSH is for connecting to jump servers and going through the jump servers to manage other machines. So here's the scenario. The server in the middle here is a jump server. From my laptop, I authenticate with a password over SSH to the jump server. The jump server then obtains a ticket granting ticket for me. So when I authenticate to the third machine on the far right-hand side, now when I use SMB, RPC, SSH, or some other connection protocol, it works. That's because the server in the middle has obtained a ticket granting ticket on my behalf, and it can use Kerberos to authenticate with these other protocols. So for example, I SSH into the jump server in the middle, and then I map a drive letter over SMB. Or I use a command line tool that uses RPC. And you know what? It'll work. I've got the smiley face on the right-hand side. So in that case, we don't have the dreaded double hop problem here. I can make a double hop. I can hop into the jump server and then make a second hop to the third machine on the right-hand side, and it does work. But notice at the bottom, I authenticate with Kerberos or with a public-private key pair to the jump server. The jump server does not obtain a Kerberos ticket granting ticket for me. And that means I can't use Kerberos to authenticate to the third machine on the far right-hand side. So if I try to map a drive letter or access an RPC service, and I attempt to use Kerberos for the authentication, it'll fail. That's because the jump server in the middle does not have my Kerberos ticket granting ticket. But notice that the SSH connection does succeed. I can go through I authenticate to the jump server with Kerberos or a public-private key pair. I can go through SSH to access the third server on the right-hand side. But there's a restriction here. I have to use key-based authentication to make it work. Remember, all of these machines have a special service called the SSH agent service. And that agent service can relay authentication requests when I'm using a public-private key pair. Now, what this means as a practical matter is that if you are planning to use SSH to connect to a jump server, ironically, you might find that you have to use a password. So that at the top you authenticate with the password, the jump server gets a ticket-granting ticket for you, and now you can use Kerberos or SSH key-based or password-based authentication to access other machines. Whereas down at the bottom, you might prefer to use key-based authentication to access your jump server instead of Kerberos, because now you can use SSH again to access the third machine on the right-hand side, and it'll work assuming that the SSH agent is running on all the machines, so that you can relay the key-based authentications back and forth between the two. All right, I know you might be new to SSH and all this is again kind of overwhelming, but this is something that will drive you insane when you're trying to troubleshoot it later on because of the complex authentication work going on in the background that you can't see. That's why on the prior slide it was so important to know about how to enable logging, including the debug or verbose logging on both the server side and the client side. Because unless you happen to know this off the top of your head, and I guess you do now because it's in the manual, unless you happen to know this, if you don't have access to the logs on the servers and the verbose logging on the client side, it'll be really difficult to troubleshoot these kind of connection scenarios. All right, so here's in the manual then, maybe at least for reference. So maybe 6 or 9 months from now, you're setting up a jump server and using SSH in this way, but sometimes it works, sometimes it doesn't work. And the question is why? All right, and hopefully the manual will help you to troubleshoot and fix it. Some best practices then for using SSH. It might be obvious, but it should be stated again. Your perimeter and host-based firewalls should restrict SSH traffic. SSH uses TCP port 22 by default, but be aware any port number can actually be used. Later in this course, we're going to talk about IPsec and how to combine IPsec with SSH for role-based port control. That's coming up later this week. Now, how are we going to install, patch, and manage SSH on our boxes? Are you going to install SSH from GitHub and get the latest version? Or are you going to install only the official version from Microsoft and then use Windows Update and your WSUS server? Remember, if a new nasty vulnerability comes out for the SSH daemon, that machine's exposed to the internet. Exactly how long are you willing to wait as Microsoft gets around to applying the patch through Windows Update? I mean, a week? A month? 6 months? I think on the whole you might be better off installing and patching from GitHub. Next, we want to do role-based access control with groups. We only allow people to connect with SSH if they have a legitimate need to connect. And that's true for both SSH and also traditional PowerShell remoting. Again, nobody should be remoting and SSHing into other boxes around the LAN unless they have a legitimate need to do so. We got to keep a lid on all the complexity here. So if only IT people and developers need to SSH or PowerShell remote into other boxes, only allow those groups and nobody else. There's different ways of enforcing this restriction. We can enforce this through the network logon right. We're going to talk about that more later in the course. Or as we just saw a couple slides ago, you can edit the sshd config file and then specify the allow and deny commands for groups or individual users. Either one is perfectly fine. You have a little bit more flexibility when you're using the sshd config file. For example, you can now restrict by source IP address. We can do that with the Windows firewall as well, and we're going to see how to do that later this week. For authentication, in general, avoid password authentication. Prefer either Kerberos or key-based. If you are using public-private key pairs, you might consider using a password manager app that can interact with or be your SSH agent. And in fact, if you are using password authentication, make it a very long random passphrase and store the passphrase in your password manager app. So many password manager apps allow you to put the password into the clipboard, and then you can paste that password into your command shell. If you are using key-based authentication, periodically rotate keys. Rotating keys means getting rid of the old ones and replacing them with new and different ones. So ideally, this would be done like every 3 months, but I know this can be difficult to manage. So at a minimum, perhaps maybe how about every year? Now, if there's an incident, you have to be ready to rotate keys immediately. So you might have scripts and other tools like System Center, Group Policy, or PowerShell scripts ready to go. So in an emergency, you can rotate your keys immediately. Also, train your users and administrators to not share their private keys with their friends. In fact, the big offenders here are the developers and the IT people. Because now, if you want to loan your identity out to someone, it's very easy. You just give them copies of your public-private key files, and then they can use those private keys to authenticate as you to other machines. So this is very tempting for the developers and the IT people, but this is bad for a variety of reasons. Next, recall that when you SSH to another machine for the first time, you're prompted to enter yes or no to confirm the host key of the other machine. In general, we don't want users to make this choice, because users will always enter yes. They won't even read the message that appears. So, you can create a file named SSH known hosts. This is a central, shared, or global known host file. And in fact, later this week, when we talk about PowerShell scripting of Active Directory, we're going to use Active Directory as a source of our known hosts key files and use Active Directory as a way of gathering these keys and then creating this file, the SSH known host file that is central and shared on a machine, shared by all the users of the box. So coming up later this week, we're going to see how to store these host keys in Active Directory. As we've seen, we've got these very sensitive key files and configuration files. Don't forget NTFS permissions and NTFS auditing. We don't want to make it too easy for hackers or malware to modify these config files or to modify the key files in particular. You might also combine this on laptops with things like full disk encryption and UEFI secure boot, preferably with a TPM chip or a hardware token like a YubiKey. Which types of keys should we use? What about the key size? The hashing algorithm? Well, later this week we are going to discuss more crypto, but the short of it is, first, we need to have a plan for managing these settings in these keys across thousands of machines. And ideally, we'll have one policy that is clear and concise for everybody to follow. For example, we want to avoid DES, triple DES, RC4, MD5, and SHA1. In general, prefer 128-bit or larger keys, like AES Galois counter mode keys. And instead of AES, you could use like ChaCha20. For example, that's what's built into the Chrome browser. You get a little bit better performance too. Now, what about your public keys? Now, RSA public keys are backwards compatible. They've been around for a long time. But for technical reasons, add 255.19, elliptic curved public keys are better. So if the cryptographers are correct and the quantum apocalypse is going to come soon, elliptic curved public keys have a better chance of withstanding quantum computing attacks than older RSA keys. Now, RSA keys are more widely or backwards compatible though, so if you're going to use an RSA key, the recommendation is to use a 3072-bit RSA key at a minimum for security. And if you have to make it smaller for backwards compatibility, then the realistic limit here is 2048 bits for RSA, but only use that key size if you have to. And never choose a 1024-bit RSA public key. In that case, that is just too small by modern standards. Where do these numbers come from? Well, for example, NSA recommends that your RSA public keys be 3072 bits at a minimum, preferably 4096 bits if you need them to last like 5 years or more because the quantum apocalypse is coming. Choosing these ciphers and key sizes, This can be fairly complex. You have regulatory issues to deal with, maybe HIPAA, Sarbanes-Oxley, maybe you work in a classified environment like in a SCIF. So to at least provide some general guidance here, check out keylength.com. That has a nice wizard on the site that will ask you questions and kind of walk you through the process of making a good rational decision about your ciphers and key sizes. And specifically for your elliptic curve public keys, then check out the site at the bottom, safecurves.cr.yp.to. In other words, safer crypto. And that'll lay out the mathematics of why it is that elliptic curve public keys in general are better than RSA keys, and more specifically, which types of elliptic curve keys. There's more than one type. And in general, the ED 25519 keys have a very good reputation as far as the elliptic curve public keys go. You don't have to be a cryptologist or have a PhD in mathematics here. In this case, you can at least use the websites and get and glean from the sites, right, some general recommendations. And really, that's where all these recommendations in the manual came from. They came directly from these two sites. And finally, some miscellaneous. Of course, enable logging and forward your log data to a SIM. Hopefully, we're going to do some real-time pattern matching, like for a dashboard and alerting. SSH has a feature called port forwarding, but because of time constraints, it just couldn't be covered in today's manual. Today is one of the longest manuals already. And port forwarding is dangerous. So if you're not familiar with it, it's best to disable port forwarding in the sshd config file on your boxes. How you do this, that's in your manual. Set a reasonable inactivity timeout, so somebody SSHs into another machine and then they don't do anything. They just hang out and do nothing for hours. Well, then you might have a policy that says that after 30 or 60 or 90 minutes of no activity, then the SSH connection is dropped. Again, this is done by editing that SSH config file, and those details are in your manual. If you do have SSH public-private key pairs floating around all over the place, and lots of authorized keys files, and known host files of various states of integrity, then be prepared for the inevitable security incidents. Have an incident response plan ready to go, like emergency scripts. So just in case, we could perhaps shut down the SSH service, or rotate keys, or start denying access to users that have been compromised. But be prepared for the compromise. In fact, later this week, we're going to discuss IPsec. IPsec is another way that we can authenticate machines and users. It also allows us to do host-based authentication and role-based authentication. That's coming up later this week. So SSH has a competitor. And I'm not talking about IPsec for VPNs, by the way. I just mean native IPsec. That's coming up later in the course. I know that sometimes you'll see recommendations to change the port number for SSH. Probably it's not worth it. Port 22 is the default, but keep in mind that if your adversary does a full port scan of your machine, they're going to attempt to connect to all of the TCP ports on the box, and they're going to find the port number. So that's just a little bit of security through obscurity. You don't get that much out of it. In fact, one of the main reasons that you change the port number for SSH is to get around other people's firewalls. For example, someone might have a firewall that blocks all traffic except for port 80 and 443. Well, if you want to, you could set up an SSH server on port 80 or 443. And then now you might be able to get past somebody else's perimeter firewall. Of course, hackers do the exact same thing. And finally, SSH 1.0 is totally obsolete. Only use SSH version 2 or later. And that's what we've been discussing today.